So let's wait for 2 minutes. Let's see other students may also join. So I guess we can start now. So am I audible? Can anyone confirm in the chat box? Okay, thank you. So welcome everyone in the week third of this deep learning IIT Ropar course. So this is a live tutorial session which is happening on every Saturday 3 to 4 p.m. So today we will discuss some of the important questions from the topics which were taught in the week 3 lecture, which was uploaded on the NPTEL portal for the Deep Learning IT Roper course. Okay, we'll start with our first question, and we'll also see some of the basic concepts. Like through the questions only, we will see some of the concepts. So the first question is, let the input to the feed forward neural network be a six-dimensional vector, and the first hidden layer has six neurons. What is the dimension of the W1? That is the weight connecting input layer and the first hidden layer. So before that, we'll see like how does feed forward network looks like, and we'll see the neurons in the hidden layer, and after that we will find this question. So basically in this question they are asking the dimension of the W1, that is the weight in the in the first hidden layer. Okay, so which connecting the input layer and the first hidden layer. So this is our feed for forward neural network. In this, you can see our inputs are this x1, x2, and xn. These all are our inputs, and this is our first hidden layer. Okay. So in this question, it is asking the dimension of W1, that is connecting the input to the first hidden layer. So it is asking the dimension of W1. So in this network, basically there are L hidden layers, L minus one hidden layers. Like total number of layers is L. So this is L minus 1 hidden layers. Okay. Like there is three layers in this feed forward neural network. So in this, there is two hidden layers. That is L minus 1. Okay. And finally, in the output, there is K classes. This means there are K neurons in the output. This is 1 dot 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 K. So if there is K classes, then there will be the K neurons in the output. So we have to see like what are the dimensions of these parameters. From here only the feed forward neural network starts. So first we'll start with X. So the dimension of X is like it is a n dimension because there is n input here in this diagram. So the dimension of X is n, that we can denote as r to the power n. Okay. And here for W, we can write this as this. You can see this path. Someone is joining. Okay. So we can this is the first hidden layer. So this path from the X1 to this neuron, this is in the neuron in the first hidden layer. So this we can write it as W11. Similarly, this one we can write, this is the second neuron in the first hidden layer. This path, the weight of this path is W21, and the weight of this path, let's suppose this is our nth neuron. So this will be Wn1. Okay. And also this from the path from the xn to this nth neuron in the first hidden layer, this can be given as Wn cross n. Okay, understood? Because there are n inputs in the input layer. So like the weights from the n inputs going to the n neuron. So the dimension of this W will be n cross 1. It will start from 1, 1, 1. Like we can write like this. Okay. So still some people are joining. So we can write here our W will be W1, that is the weights in the first weight connecting the input to the first hidden layer. That will be W1, 1, 1, W1, 1, 2, dot, 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 W1, 1n, and here W1, N1, W1, N2, dot, 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 Wn, N. So the dimension of W1 is n cross n. Okay. So in this question, it is written that the input is a six-dimensional vector, means x x1 inputs are x1 to x6, x2 dot 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 x6. So here n is our 6. Okay. And now they are asking the dimension of W1. So W1 will be 6 cross 6. So the dimension of W1 is R to the, means in the real domain, 6 cross 6 vector. Okay. So the option A is correct. Got it? Any doubt in this question? Similarly, we can see here, this is for Wi, the dimension is n cross n, and this bias like Bi in each layer, uh, you can see that B1 is connected to each neuron in the next hidden layer. So the dimension of Bi is n, so that is denoted as this. And in the last layer, you can see like here in the output layer there is K neuron. Okay. So the dimension of B will be K, because it will connect to the first neuron, second neuron, third neuron, and up to the kth neuron. So this is the kth neuron. path from the B3 to kth neuron. So the dimension of BL, that will be K, because there are K neuron in the output layer. Okay, so this point also you understood. And what will be the dimension of WL? WL is the weight in the Lth layer. So that is the last layer. So here L is equal to 3 in this diagram. So what will be the dimension? That will be N cross K, because there is uh, 3 neurons here, you can see, and in the output layer that is 2 neurons, that is 1 and 2 in this diagram, as you can see. So it will be W 3 have the dimension 3 cross 2. Okay, so that is N cross K, because here K is equal to 2 and N is equal to 3. So our WL will have the dimension N cross K. So any doubt in this question? Just let me wait. I will check whether the recording is on or not. Yeah, recording is on. So any doubt, like what will be the dimension of each parameters? If you have any doubt, then you can write in the chat box. I will be reading the messages coming in the chat box as well. Okay, so I guess no doubt. Then we can move on to the next question. Now, in this question, can you please answer? The question is, the pre-activation layer at I, that is AI, can be best described as. Can you answer this question? Okay, so let me explain what does this question says. The the pre-activation at layer I, that is AI, can be best described as. As you can see in this diagram, that this is our A1, A2, and A3. Option B, yeah, that is correct. Nice. So here you can see this A1. How we can write this A1? So we have to do the weighted sum from the previous input. Like you can see, we can write it as like this is our A1. So the A1 is denoted as means here it is A1, because this is the pre-activation in the like in the first layer. That's why it is A1. But when it will connect into the second neuron, it will be A12. So in this way, in the first layer, we can write the A vector as A11, A12, A13. That is equal to B11, B12, B13 plus, you can see here that this B is adding in the each term, multiplied with the W vector, W11, W112, W113, W121, W122, W123. Let's suppose for this three layers, we are writing this expression W131, W132, W133. This W is getting multiplied with H. Okay. So like here, this is our H naught 1, H naught 2, and H naught 3. But in the first layer, H naught is our input layer only. So we can write here H naught 1, H naught 2, and H naught 3. This is equal to our input only. That is equal to X1, X2, and X3. So how we can write A11? That is equal to B11 plus the weighted sum. Got this point? Okay. So the correct option will be the weighted sum of all the inputs at layer I minus 1. Okay, option B is the correct option because it is taking from the means previous layer. That's why it is I minus 1. Okay, any doubt in this question? Now coming to the next question, that is question 3. The pre-activation at layer I and AI can be best described as. So what will be the option? Like there are three statements given in this question. That is the G function is applied to every element in the vector. I'll see the chat box. If you can answer, then you can answer for this question as well. Then the statement 2 says that G can be a logistic function. The statement 3 says that G cannot be a tanh function. So what is the correct option? Like which statements can best describe the pre-activation at layer I? This is very simple question. Like this G depends on us. So G can be logistic or tanh. Like we can take any pre-activation function. But the option 2 is correct. But option 3 is wrong because it is written G cannot be a tanh function. It can be. And G is applied to every element in the vector. Yes, we can apply G in the every element. Okay. So the correct option is option D. That is 1 and 2 statements are correct. Okay. No, option B, someone has written it. It will be option D. That is 1 and 2 statements are correct. Because we can apply G like in the definition of neuron only we have seen whatever input is coming, weighted sum. Here, our output is that is the G of whatever input is coming. So it can be applied to every element in the vector. If let's suppose W1, X1 plus W2, X2 is there, then it can be applied for each and every element in the vector. Okay. So now we'll move on to the question number 4. Like given that the output y is a probability distribution, sigmoid function cannot be used an output function y. So the four options are given. Can you answer for the question number 4? Like it is given that output y is a probability distribution. It is probability distribution means the value of y will take from 0 to 1. Okay. And also the summation of all the outputs should be 1. So the properties of probability distribution function is like summation of yi is equal to 1 and lies in the range of 0 to 1. Okay. So why we cannot use sigmoid function? Can anyone answer? Option A. Someone is answering. Okay. Let's see all the option one by one. So the first option says that the range of output values for a sigmoid function is 0 to 1. Yeah, that is the correct statement. But here it is asking why it cannot be used. So for this reason, like there is no problem because the range of output values for each output is 0 to 1. And in probability distribution also it is 0 to 1. But you see the second option, here it says that the sum of all the output values will not be equal to 1. That is the correct answer, because when you take the sigmoid function, each output, like each neuron in the output layer, y1, y2, they can be between 0 to 1, 0 to 1. Let's suppose y1 is 0.9 and y2 is 0.2, then the sum will be 1.1, that is greater than 1. So the sum of all the output values will not be equal to 1. That is the problem in the sigmoid function. Okay, like summation sigma yi, that is not equal to 1. But if we take softmax function, the summation is equal to 1. I will just show you how. We were here, not here. Hmm. So, like how we write our softmax function? Can anyone, like this is our simply e to the power, like how we write our softmax function? E to the power. Let's suppose there are three outputs. So yi divided by summation of e to the power yi. Let's suppose we have three neurons in the output layer, that is y1, y2, y3. Still some people are joining. Okay. So let's suppose we have three neurons in the output layer. So when you do this softmax function, this will be like, let's suppose the probability is 0.2, 0.4 and 0.4. So what will be the summation of all the value here? That will be 0.2 by e to the power 0.2 by, okay, softmax of y1 is equal to e to the power 0.2 plus e to the power 0.4 plus e to the power 0.4. So now when you do this, like summation of all this value, you will get e to the power 0.2 plus e to the power 0.4 plus e to the power 0.4 divided by e to the power 0.2 plus e to the power 0.4 plus e to the power 0.4. This is softmax of y1 plus y2 plus y3. So this value comes 1. So it obeys the properties of probability distribution function, where the summation of all the value is coming to be 1. But in sigmoid function, each outputs are independent. So it can give value from 0.9, 0.0 to 1. So let's suppose if we take y1 is equal to 0.9 and y2 is equal to 0.2, the summation will exceed the value 1. So that's why option B is the correct option. That is, sum of all the output values will not be equal to 1. So anyone answered option B? Yeah. No, option A, someone answered. Okay, option B is the correct option. Now you can see option C, range of output values does not confine to 0 to 1. Like this is the wrong option, because sigmoid have values in between 0 to 1. And sum of all the output values is always 1. That is also wrong, because in sigmoid, sum of all the output value is not 1 always. Okay. So now we'll move on to the fifth question. So in this question, it is given that the output is probability distribution function, like we have seen in the last example only, that is question number 4. So here also The output is probability distribution. Identify the statements that are true. So can you answer this? So we'll see one by one each statements. The statement is saying that statement 1 is saying that activation function is softmax. So is this the correct option? Yes, statement 1 is correct. Statement 2, activation function is linear. We have already seen why for probability distribution the activation function is softmax, because the summation of all the output value gives to 1. Okay, so option 2 is wrong. Third option is loss function is squared error. So one thing you should note, as you have studied in the week 3 lecture, that whenever we are using softmax, then we are using the entropy loss. Okay, cross entropy loss. So option 1 and option 4 is the correct option. So option B is the correct. And here you can see in this table also, here like if the output is real values, when the output is real value, any real values, then the activation function will be linear and loss function will be the squared error. Okay, that we have done in the MP neuron and multiperceptron MLP. Now when the output are probabilities, so here our loss function will be cross entropy when the output activation will be softmax. So using this table we can answer this question number 5th. This is a probability distribution. So activation function is softmax and loss function is the entropy function. Okay. So any doubt, then you can write in the chat box. Else we will move to the question number 6. Okay. So answer for this question, that for all the layers from input to the last hidden layer during forward propagation, the activation function is computed as follows. AK is equal to BK plus WK HK1. What is H naught to compute A1? So we have to, anyone give the answer? No. Can you answer for this question? Like we have already discussed in the previous question here, as you can see, our A11 is becoming, here you can see like this H naught 1, H naught 2 and H naught 3. This value is equal to x1, x2 and xn. H naught n is equal to xn. What, according to the discussion in the 3 to the week first, question options are not there. I could not understand what you wrote. So here our HK1, what will be the answer? Like in the initial layer, our H is H naught 1 is equal to x1, H naught 2 is equal to x2, and H naught n is equal to xn. Okay, this you can see in the diagram of feed forward neural network. Here you can see. I'll take some other color pen so that it will be visible. Here you can see that this is our H1 that is coming as a that is the output of this neuron. But here this is our H naught 1. This is equal to, simply is equal to x1, because there is nothing coming from the input here. That directly x1 is coming as the input, and that is equal to H naught 1. So our initial H naught is equal to x only. That is the input. Okay. So what will be the correct option in this? that is x. Okay, because our h naught 1, h naught 2 and h naught 3, this is simply equal to x1, x2 and x3. Okay, so our h naught vector is x vector. So the option A is correct. Any doubt in this? If you have any doubt, then you can write in the comment box. Here we can also like write it if some many of the students have joined now. So here we can see that our pre-activation, that is H A1 1, A1 2 and A1 3. This will be the summation of W1. This I have already explained in the previous slide, but still some students have joined now. Okay, so here you can see that the initial activation function, that is h vector here, this is simply is equal to x1, x2 and this is xn. Okay, if we have taken three neurons here, so this is h naught 1, h naught 2 and h naught 3. So the correct option is x. Okay, understood what will be the value of h naught to compute the a1? Like you can write here a11, that is equal to w111 into h naught 1 plus w112 h naught 2 plus w113 into h naught 3 plus b11. And here our h naught 1 will be x1, h naught 2 will be x2 and h naught 3 will be x3, that is the input. So in this way we can write a11. Similarly we can write for a12 and a13 also in this way. Just multiply this, do the matrix multiplication, you will get. So here for calculating a, we require h naught and this h naught is equal to the input function. So is this question done? If you have any doubt, then you can write in the chat box. I have not seen any doubt. Okay, that's good. So now we'll move on to the next question. I consider the output classes for random variable x to be, let's suppose there are four bird name is given, that is parrot, dove, cuckoo and owl. Owl. So like there are four classes here, four birds are there and some images are given and you have to classify them in one of the four classes. Like some images have been given and we have to classify like that this image belongs to which class of this bird. Okay, so for example, if the actual image of is of all, the output will be 0001. Identify the best activation function to minimize the loss. Okay, so what will be the answer? This is very simple question. Yeah, option D, because this will follow the probability distribution function, because whatever the sum of all these will be equal to 1, and so the option for probability distribution softmax is best, and the loss function will be the cross entropy. We will see, and in the next question, like we will see how the loss function is cross entropy in the softmax function. Like why that is better? Why don't we use the mean squared error? So question 7 is very easy one. Like we have to directly classify a given image into one of the four classes. Okay. So now coming to the question 8, that is pick out the statement that is true for an event with high probability. Now this question is based on the information content and probability value. Okay. So like if some event have one like probability is equal to 1, then that that event does not contain much information. Like sunrise in east, that is the that probability is equal to 1. So this information is known to everyone and this does not have a much information content. So there is one relation that probability is, sorry, information content is inversely proportional to the probability. Okay. So this is one relation between the information content and probability. So here in this question, it is asking that which statement is true for an event with high probability. If probability is high, this means information content will be low. So which option is correct? Option B. Okay. And also the information content is equal to log to the base. Like this is log 1 by pi. You can write it minus log pi. So any doubt in this question? Like there is simple relation, that is the relation between the information content and the probability. Okay, so we'll move on to the next question. Consider a feed-forward neural network with x-dimensional vector and the first hidden layer has x neuron. What is the dimension of the B1 bias between the input layer and the first hidden layer? So in this question, like it is asking that there is x neuron in the first hidden layer. So what will be the dimension of our bias vector, that is B1? So let's see the feed forward neural network diagram. Here you can see what is the given number of neuron, that is x neuron. So let's suppose this is 1, 2, dot 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 x neuron are there. So what will dimension of B1? So this will be B11, this will be B12, and this will be B1x. Okay, so dimension will be x. Understood? I will erase this because it will confuse when I will share this note, because this is from different question. In the previous question we have taken n, but in this question the number of neuron given is x. Okay, so the dimension of B1 will be r to the power x. That is the x dimensional value. Okay, any doubt in this question? Like these all are very simple question. When you go through the lecture, you can see the derivation of how to calculate the gradient using the back propagation to minimize the loss function. Those thing is there in the lecture. If you see, then these all are the basics for those type of derivations. Okay, so we will move on to the next question. That is question number 10th. This is in a feed forward neural network. The hidden layer connect to the output layer has P neurons and the output layer has Q neurons, each corresponding to one output class. Comment on the dimension of the weight connecting both layers. So this is the, let's suppose our input layer x1, x2, dot 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 xp. So there are several hidden layers in between, and the hidden layer just before the output layer is this. So this will be like first neuron, second neuron, third neuron, fourth neuron, and there is a p neuron. Okay, and the output layer has the q neuron. One, two, q neuron. So in this given question, the hidden layer connecting to the output layer is having p neuron. Okay, so there is a p neuron in the hidden layer which is connecting to the output layer, and the output layer have q neuron, and each neuron corresponding to the one output class. So we have to comment on the dimension of the weight connecting both layers. Let's suppose this is the lth layer of the weight. So what will be the like dimension of wl? This will be wl 11, wl 12 up to wl 1q. Okay. Similarly here wl p1, wl p2. This is our weight matrix wl pq. So the dimension will be R P cross Q. That is option C is correct. Yeah, correct option. Yes. Hari also replied option C. That is the correct option. So here the W vector will be the P cross Q. Okay. So the dimension of WL is P cross Q. So if anyone have any doubt, then you can ask in the chat box. Now we can move on to the next question. Like till now, if anyone is having any doubt, then you can ask. No doubt? Then okay, we'll move on to the next question. So in this question, it is given what will be the objective function when the output activation function is softmax and y hat is the actual and estimated probability distribution. Okay. So as we all know that when the output function is activation function, our loss function that is given as that is a cross entropy. So how to denote the cross entropy loss? That is equal to summation of y actual and y predicted. It will be in log yp. And here's the minus sign. That's why, like this minus sign, why there is a minus sign? Because if you take log 1 by yp, it will become equal to minus log yp. Okay. So that's why we have taken a minus sign. So this is our loss function. Now, what will be the objective? And one more thing we know that let's suppose there are like L classes in this, or we can, for simplification, we can write here yi, like yi is the actual value for the ith classes and yi hat is the predicted value. Okay, like estimated value, and I is equal to 1 to L, or we take k only because in the previous example also we took k. So there are k class in our data set. Okay, so our output vector, like if you know the output, let's suppose like in the previous question there was like four bird was given. and the output was like 0001. Okay, if you know that the bird is all, the figure which is given, that is all, so output will be 0001. Okay, so in this also we'll get 1 when I is equal to L. Okay, for we know that for the Lth value, this y is equal to 1. Let's suppose like something y will be something like this, 0001, something like the k classes are there. So kth value, that is a 0. So this will be k cross 1, and some value, any one value will be 1. So let's suppose at the Lth place it is 1. So L theta is equal to, like we can write first this, yi is equal to 1 if our I is equal to L, that is the true class level. Like when we know that this is the output, so at that true class the output will be 1. So that occurs at the I is equal to L. Okay, and it will be 0 for all other levels. So now we can write, I'll just add one page here. Hmm. So our L theta, this will be is equal to, it was minus yi log yi. So I is equal to 1 to k, like there were k class in our data set. So at I is equal to, yi is equal to 1 when if I is equal to L, and yi is equal to 0 otherwise. So for all other value, this yy will be 0, so multiplication will be 0. So we will ignore that term in this summation. So our L theta will be, like when I is equal to L, it will be minus, this yi is 1 into log yl. This is equal to minus log yl. Okay, this is our estimated value. That's why we have given hat here. You can see this is estimated value, and this is the actual probability belonging to that class. So this is our, in this question it is asking the objective function. So now we have to, this is our objective function only. So either we have to minimize the L theta, that is equal to minus log y L hat, or we can take the negative of this and maximize it, that is maximize log yl hat. Okay, so this is our objective function in this kind of, when the softmax is our output activation function. So if you have any doubt, then you can write in the chat box. I cannot see any doubt here. Okay, so I will move on to the next question. Like this is the question based on finding the entropy. So there are two events, like a event is there that have two possible outcomes, that is y1 comma y2. So the probability of this is y1 is 1 by 2 and probability of y2 is 1 by 64. So in this question it is asking us to find the entropy. So what is the entropy? H, that is equal to summation of pi log 1 by pi. Okay, so we can also write it as minus pi. We can write it like this. So we will find here entropy, that is equal to I is equal to here 1 to 2. So that is equal to P1 log 2 1 by P1 plus P2 log 2 1 by P2. And this term is our information content as we have already seen in the previous question, and that is inversely proportional to the probability. Information content is inversely proportional to the probability. So here we can calculate now. We can substitute the value. Our entropy will be half this log 2 1 by P1. P1 is 1 by 2. So that will be equal to 2 plus 1 by 64 into log 2 64. So H is equal to half into 1 plus 1 by 64 into 6. So what will be the answer? That is equal to 64 by 32 plus 648. Am I right? It will be it will be P log 1 by Pi, but that can be written as this also, that is minus log 2 1 by Pi, because we know that log 2 1 by Pi is equal to minus log 2 Pi. So you can use any formula, this, either this, okay? You can use any formula. I guess this calculation is something wrong. So this will be 1 by 2, log 2 is 1, 64. You can deduct this 3, 32. Now you can take 32 here. That will be 16 plus 3, that is equal to 19 by 32. So this is our entropy. Okay. So any doubt in this question? Okay, understood. So for today's we have this only around like we have discussed 12 question today. This was very simple question. Like from next time I will try to keep some questions like from the outside the slide notes, like some tougher question, so that you will also gain some additional knowledge through this tutorial session. So till now I were taking the questions from the class notes and the simple questions which can build the concept for that week lecture only. So from now onwards I will keep some tough question from the week 4 tutorial session. So it will be good interacting with you all. So but I expect all of you have seen this week 3 lecture, because whenever you come to tutorial session, it is good when you see the lecture, then you will be able to understand all these things very easily. Okay. So today we can bind up here. Okay. Thank you, Hari. And I expect in the next week, I expect all of you to watch the week 4 lecture and come in the tutorial session. So thank you all. We can close the session now. Bye bye.